So the last thing that I'll talk about is limits at infinity. And this is where we imagine that x goes to an arbitrarily large value. So if we take the example 1 over x, we should know how that looks. And very rough, bad drawing with the mouse, but 1 over x gets arbitrarily close to 0 but never actually touches it, and therefore the limit is 0. Now, that's a fairly obvious example. Another obvious example is the limit as x goes to infinity of x, right, where f of x is equal to x. Then as x goes to infinity, clearly this goes to infinity, so the limit doesn't exist in that case. And this is in general true, right? You could view x as x over 1, where the degree of the numerator is 1, and the degree of the denominator is 0. So the top has greater degree, and it goes to infinity. Here, it's just the opposite. The top has degree 0, the bottom has degree 1, so because the top has smaller degree, the limit is 0, and that always happens. So, for instance, in this problem, it's very easy to know what's going to happen. The limit as x goes to infinity is infinity because the degree of the numerator is greater, and so the whole thing goes to infinity. Now, imagine that we flipped this upside down, right? Take this to the -1 power, which you should very readily understand means flipping it upside down. Now the degree of the numerator is smaller, and it would go to 0 instead. So that's the general rule. Now, what happens when the degrees are equal? In that case, you get the even more interesting fact that the answer is the ratio of the leading coefficients, right? The -3 divided by 2 is the limit of this function. And that's the full set of rules for how to get limits at infinity. Now, sometimes you have to do slightly sophisticated algebra tricks to get everything to work, like squaring the root or something like that, or rooting the square. And we'll talk about those in the exercises, but this is how you get limits at infinity. Of course, certain other functions you just should kind of know the graph and be able to figure out the limits based on the graph. Like, of course, x squared goes to infinity, or square root x goes to infinity. That should not look so linear. It should look like a curve like that. That's square root x. You should know that the logarithm, which comes up from -infinity, goes to infinity, and so on. So exercises in the next video.